Okay, so in this today's lecture, I will discuss some formulas for condensed matter physics, which will be helpful for competitive exams. So here I will discuss basically mainly two chapters: crystal structure and superconductor. Okay, and I will discuss little bit of the magnetic properties of material. So what is, suppose I ask you, what is this crystal? So crystal is basically lattice plus basis. Basis means atoms and other things, and lattice, you know, that collection of orderly collection of the imaginary points. Okay, so I asked you what will be n effective. Okay, n effective will be ni plus nf by 2 plus nc by 8. What is this ni? Ni means the interior atoms, they will contribute with one factor. Next, nf are the atoms on the faces, nc is the corner atoms. Okay, so in this way you will find the ineffective. And next we will discuss some known relations. For simple cubic, you know n effective will be 1, for bcc it will be 2, for fcc it will be 4. And you know these relations also: 2r equal to a for simple cubic, 4r equal to root 3a for bcc, and fcc it will be 4r equal to root 2a, where r is atomic radius and this a is called, that is, constant. Okay, next we have to know what is this Miller indices. Suppose I have given for a plane, given those intercepts along the three axes x, y and z, and I have taken an example here. So here it is 3a, 2b and c. These are the intercepts along those axes. Reciprocal, I have to take the reciprocal then, and I have to multiply with the lattice parameter along that respective directions. I will get this type of fraction later on. As you can see, if I just multiply with the 6 factor, so I get the uh, Miller indices. In this way you can find Miller indices. Okay, this is an example. uh, you can do similar way to get other cases also. Okay, so you can see here the Miller indices here is 2, 3 and 1. Okay, next we have to know what is this interplanar spacing. This is represented as d. So this spacing is 1 by root over h by a whole square plus k by b whole square plus l by c whole square. So h, k, l are the Miller indices and a, b, c are the lattice parameters and corresponding those directions. Okay, note that this formula only holds for cubic, tetragonal and orthorhombic. Okay, next we have to know what is the packing fraction. So packing fraction basically is the ratio between volume of atoms in unit cell divided by the volume of unit cell. Okay, good. Next we have to know for cubic cell how this lattice parameter depends on the mass density. So A is basically equal to An effective multiplied by molar mass divided by Avogadro number multiplied by mass density, and cube root of it will give me this A, lattice parameter. Okay, next another important formula is this Bragg's law. Bragg's law is 2d sine theta in lambda, where this theta b is the Bragg's angle. Bragg's angle basically, suppose one ray is let me show you something here. Okay, just give me a second. Okay, sorry. Suppose this is a lattice point, so this angle will be my theta b, and this is called as Bragg's angle. I know my handwriting is a little bad. It's very bad, but I just don't want to discuss some formulas, and I'm little bit still now not so much familiar in writing this bad also. Okay, so lambda is wavelength, d is interplanar spacing, and n is the order of diffraction. By plugging those values, you can get the required parameter that will required in your numerical. Okay. Next, you have to know how you will get those reciprocal lattice vectors. So they are related by in this way, where the small abcr corresponds to the direct lattice vectors and this abc are reciprocal lattice vector, capital ones. Okay, they are related by in this way 2 pi b cross c divided by a dot b cross c. Okay. And similar thing, you can see that there is some kind of a cyclicity also there, B, C, A. So it will help you to remember those. Okay. Now there are some important results from the structure factors that I want to discuss with you, that which reflections will be allowed from the planes. For simple cubic, H scales all values are allowed in this regard, and for BCC H plus K plus L, if even, then those Miller indices will give me required reflections, and for FCC H scales will be either all even or odd. There will should not be any sort of mixture. Okay, good. Next, I will discuss some formulas of superconductor. How critical field at temperature T is related with critical field at temperature T equal to 0 Kelvin. So it is related like this. HCT equal to HC0 1 minus T by Tc whole square. Okay, and how this penetration depth related, it is also related in same sort of fashion, just here 4, it is power, it has 4 and this minus 1 by 2 factor. Next, we have to know for type 2 superconductors, you all know that there are two types of superconductors, type 1 and type 2. So, how the critical field formula will be for it? It will be phi naught by pi lambda square, where phi naught is the flux quanta, which is given by h by 2e. E is the electron's charge. Okay, and hc2 will be given by phi naught pi epsilon, sorry, it's not epsilon, xi square, where this xi is coherence length. Okay, and this coherence length is inversely proportional of the band gap. Okay, and there is another important concept, that is isotope effect. Okay, where Tc m half is constant. Okay, and if I go back to the previous page, here Tc is the critical temperature and m is the mass. Okay, it is also very helpful formula for solving these numericals. Okay, next I will go to Josephson effect. Josephson effect basically AC current that flows in presence of biasing. Okay, where the superconductor junction is there. So here the frequency of the AC current is given by this formula 2EV by H cross. Next, I will discuss very small things about magnetic properties. So basically, for paramagnetic cases, you know this chi, the magnetic susceptibility is related like this, C by T, where T is the temperature, and for ferro, it will be chi equal to C by T minus Tc, where Tc is the Curie temperature, and for antiferro, it is C by T plus Tn. At home, you should try to do the graphs between chi and T, that may be helpful for your exams. Thank you. So that's it. It is a very quick revision regarding those some of those important formulas that I want to discuss. Thank you.